students, good morning. In this lecture we are going to discuss about the phasor. What is mean of phasor and what is the phasor diagram. So here, to study the AC circuit, we have already discussed about the EMF inducer and the current. In AC circuit, if we representing alternating current and alternating EMF, that is I and E, alternating current and alternating EMF as a rotating factor, when we are going to represent these two quantities in the form of vector or rotating vector, I and E are represented as a rotating vector, and if there is some angle between this current and EMF, then the angle between these two quantities is called as the phase, and the vector which represent this AC current and AC EMF, that vector is called as the phasor. So here we can also say that the phasor is the quantity which is in the form of vector. Phasor is the quantity which varies sinusoidally with time, and it can be represented by projection of rotating vector. Here a circle is taken and this is the radius vector, r vector. Suppose here this is the graph which represent the EMF or current in AC circuit. Now suppose this is the peak value of current, that is we can say I naught, and we know that in AC circuit the current varies with time, and this is the phase angle at every point at that instant. This current varies from minimum value, that is 0, to high value, then again to 0, and then negative high value, and then again 0. As well as EMF also varies from 0 to high value or peak value. Here we can consider this is the peak value of current, and this is the amplitude of this waveform. Maximum displacement on either side on this figure. This is the amplitude of this waveform which is generated in the AC circuit or of AC current. And here we have taken a vector whose length, the rotating vector whose length is equal to the amplitude of this waveform. And this quantity, to explain the phasor, the quantity must satisfy the 2 points, that is that quantity must vary sinusoidally with time, and we know that the current in AC circuit varies sinusoidally. We get here sine waveform, and it can be represented by the projection of rotating vector. Now we will represent this projection of rotating vector, or this quantity in the form of projection of rotating vector. Now when this vector at this position, that is the phase angle is equal to 0, at this time t is equal to 0, the vector is along the x-axis. When this vector rotates from this point to at this point, point. Then when we take a projection of this vector on the y-axis, when we take a projection of this vector on y-axis, this projection gives the instantaneous value of current. That is, you can say this value is equal to I naught, that is peak value of current, and this vector indicates the peak value of current, and therefore this projection indicates the instantaneous value of current. That is, we can say I naught sin omega t. I naught sin omega t. And this is the peak value which this vector represents. As this vector moves from this point here to at this point, the angle between the OX or axis and the vector position is of 90 degrees. That is, angle is pi by 2 here. In case when vector is at this position, the angle is pi by 2, and we get the peak value of current. And this is the when we take a projection of this vector on the y-axis, that is projection will be here, and therefore this vector gives the peak value of current, and therefore we can say this vector is a quantity which varies sinusoidally with time, and it can be represented, the projection of rotating vector, the quantity can be represented by the projection of rotating vector. When this vector moves from this point to this point, the angle is of 180 degree. That is, at that instant the current is 0. Here we get the current as a 0. When this vector rotates through angle at this position, the vector is at this position, then this angle is of 3 pi by 2, or we can say 270 degree, and therefore we get the negative value of current. Then when vector rotates from this point to mean position or original position, then we again get a 0 current. That is complete one rotation. Then this wave also complete one cycle, and the angle is of 2 pi, and therefore the angle is here, total angle is of 2 pi, that is 360 degree. When this vector rotates from this position to this position again, and we get this type of wave here, and this is called as the phasor. तर या ठिकाणी हा जो रोटेटिंग वेक्टर आहे, ह्या रोटेटिंग वेक्टरला आपण काय म्हणतो, फेजर म्हणतो. तर या ठिकाणी आपण फेजर डायग्राम ड्रॉ करू शकतो अशा पद्धतीने. दिस इज द peak value of current. Then we can draw projection of this vector on y-axis. This is the x-axis, origin O, and therefore this will be the angle omega t. The angle between the OX and the vector I naught is the omega t, and this value is the instantaneous value, or we can say here I naught small I naught sin omega t. If you take a projection on the x-axis, then this position we get in the form of cosine. The value of I is I naught cos omega t. If there is a no phase difference between the current and EMF, there is no phase difference between current and EMF, then we can draw a figure here in a same angle or same way. That is, this will be the peak value of EMF, this is the peak value of current. This vector indicates the peak value of EMF. When we take the projection of this vector on y-axis, then we get the instantaneous value of EMF, that is E naught sin omega t. Here this value is the E naught cos omega t. Here there is a no phase difference between the current and EMF. We can represent this in this way. This is the sine wave for the current. When we draw the graph for E, then we get this type of graph. As the EMF here increases, the current also increases. As EMF is maximum, the current also maximum. As EMF is 0, the current also 0. Then again, in this case, the EMF is negative, then current is also negative. Here at this position, the EMF is 0, then current also 0. And this graph can be represented in the vector form, and therefore we can represent it here. And this diagram is called as the phasor diagram. This is the phasor diagram. This diagram is called as the phasor diagram. So here, to draw the phasor diagram, the quantity must be varied sinusoidally, and it can be represented by the projection of a rotating vector. So here these two quantities are represented in the vector form. Here two quantities are represented in the vector form. There is no phase difference between the current and EMF. Both are in the same direction at every point, and therefore the arrow or vector, the direction of vector of I naught and E naught is same. That is, the direction of current and EMF is same at every point, at every instant. And this diagram is called as the phasor diagram. Now we can discuss the different type of AC circuit by using the phasor diagram. We will discuss the different type of AC circuit. The different types of AC circuit. First at all, we will discuss about the AC voltage applied to the resistor. AC voltage applied to resistor. Now take a resistor. This is the resistor. R is the resistance of this resistor, and the AC supply is given to this resistor. Here AC supply is given to this resistor. This is the symbol of AC supply. E is the EMF of this AC supply. R is the resistance of this circuit. Here an AC voltage is supplied. AC voltage is supplied to the resistor, to a resistor. AC supply or AC voltage is supplied to this resistor. Then when we give the supply to the resistor, or when this resistor is connected to the AC supply, then we know that E is equal to the equation of E, which is derived from the AC generator, that is E is equal to E naught sin omega t. E is equal to E naught sin omega t. And also we know I is equal to I naught sin omega t. Say equation number 1 and equation number 2. E is equal to E naught sin omega t and I is equal to I naught sin omega t, where E is the instantaneous voltage, E naught is the peak value of voltage, then omega is the angular frequency. In this equation also, this I is the instantaneous voltage at time t. I naught is the this I is the instantaneous current in AC circuit. I naught is the peak value of AC current and omega is the angular frequency. Now let E be potential drop across the resistance. E is the potential drop across a resistor. Then we can write E is equal to IR. That is, the potential drop is equal to current into resistance. E is equal to I into R. Say equation number 3. From equation 1 and 3. From equation 1 and 3. We can write here this IR is equal to E is equal to E naught sin omega t. Now here we can write, take this R to the right side, then this will become E upon R. I is equal to E upon R, or I is equal to E naught sin omega t upon R. Now put the value of I from equation 2. Put value of I from equation 2. Then we get this I is equal to I naught sin omega t is equal to E naught sin omega t divided by R. This sin omega t will be cancelled on the both sides, and therefore this I naught is equal to E naught upon R. I naught is equal to E naught upon R. Comparing I naught is equal to E naught upon R with the Ohm's law, that resistor behaves similarly for the AC and DC circuit. If we compare this equation with the Ohm's law, that is Ohm's law, that is I is equal to V upon R. We know the Ohm's law, equation of Ohm's law is equal to V is equal to IR, or I is equal to V upon R, where I is the current in DC circuit, V is the potential difference, and R is the resistance of circuit. Here also this I naught, this is the peak value of current or total current through the circuit. Then E naught is the potential and R is the resistance of circuit. This equation is of AC circuit, this equation is of DC circuit. When we compare these two equations, that is AC circuit and DC circuit, that resistor behaves similarly for the AC and DC. Means the resistance in the circuit behaves same in AC circuit and DC circuit. That is, it plays the same role in AC circuit and DC circuit. Hence, R in DC and AC circuit is same. R can be reduced, DC as well as AC. We know that the R opposes the flow of current. Here in this circuit, this R also opposes the flow of current in the AC circuit. That is, this resistance plays same role in AC circuit and DC circuit, that R reduces the DC and also AC. For alternating current and instantaneous current, if there is a phase difference between instantaneous current and alternating current, they are in phase, both E and I reach to zero, minimum and maximum value at same time. We can draw the diagram for the already we have drawn this diagram, that is graph of E and I versus omega t. This diagram can be drawn as this type. We know that current is always less than the EMF, and if there is no phase difference between current and EMF, then we can say this is the peak value of current and this is the peak value of EMF. The phase angle path to path. This is negative value, negative peak value minus I naught, and this is the positive negative peak value of EMF E naught. This will be plus, this will be minus. What is the region? Graph of E and I. This is the graph of E and I versus omega t. and phasor diagram for the purely resistor. We have already see the phasor diagram of purely resistor. I will again draw this diagram. Phasor diagram for purely resistor. Here, this is the vector I and this is the vector E. Both are in the same direction. This is the angle omega t between x-axis and the vector. This is the y-axis. When we use the projection from this point, we get this instantaneous value I naught sin omega t of current, and this will be the instantaneous value of EMF, that is E naught sin omega t. This is the phasor diagram for pure resistor. This is the phasor diagram for pure resistor. We can also give the projection of these two vectors on x-axis. Then we get I naught cos omega t and E naught cos omega t at that point. Now, in the next point, we will discuss about the next phasor diagram. This is the phasor diagram for the pure resistor.